Hey guys, this is Mr. H. Hey, I wanted to do a video on the DeltaMath assignment, rational versus irrational numbers. There's 4 different skills that are kind of being tested or in this DeltaMath assignment. And what I'm going to do is I'm going to do a few problems from each kind of skill so that you understand what you need to do. You're definitely going to need the calculator, and I want you to learn how to use the calculator since you're going to have this when you're taking it on the region. So let's go. I'm going to start by, you're going to have some problems like this. It says convert this fraction below into a decimal. And the easiest way to do this is just to write it 13 divided by 40. Now you've got to put a decimal in there in one of the 2 numbers at the end so that the calculator knows that you want a decimal. Otherwise, it's going to give you just a simplified fraction. That's not what we want. We want it to be a decimal. So what you're going to do is just go 13 divided by 40. And then at the end, put a decimal point. And then the calculator knows you want it as a decimal. Then you press enter. And that's what it is. It's just going to be 325. And then you submit it. And it says that's correct. All right. So those should be pretty simple. This one says convert this into a decimal. I know this is going to be 0.18, but if you do 9 divided by 50, put a point in there, it knows you want a decimal, so it says 0.18, and then we have it. So boom, we're done, submit it. It says wonderful. All right, so that's what you're doing. You got to use the calculator. If you're trying to convert it to a decimal, you got to make sure that the division has at least 1 decimal in it. All right, let's go to the next one. This one is going to be converting from decimals to fraction. All right, so basically you're going to go the other way. So it's going to be 0.135. And then you're just going to do menu 22, and you're going to get this, and it's going to say approximate a fraction. And there it is. And it simplifies it for you, which is really good. So this is going to be 27 divided by 100. And then you say, yep, submit it. And it's, oops, what happened? Oh, I'm sorry. It should have been 27 divided by 200. Oops, my eyes are bad. But that was right. I just keyed in the wrong thing. That's my bad. So let's go. New problem. All right. So I need to convert this to a fraction. So I would just go 0.79, and then I would do menu 22. And then I would go enter, and this one is 79 over 100, which is a pretty basic one because that's 79 cents. So that's 79 100ths. All right, so boom, that's easy. New problem, 0.835. I think this will be the last one that I do of these. And I want to convert that to a fraction. So I'll go menu 22, and then we got 167 over 200. 167 divided by 200. Bang, submit it. Wonderful. All right, let's go back, look at some other ones. All right, now these are the ones, we're saying that these are actually rational numbers. So that means that we should be able to convert these into fractions. Now, the easy way to do this is that 0.91 is the same thing as this. 0.91. 91, 91, 91, 91, 91. Do a bunch of them. 91. Do about 10, and then do menu 22 again. Menu 22, and then it says, oh, that should be 91 over 99. 91 divided by 99, and that is correct. All right, let's do a couple more. All right, this one is convert 0.8777777. So all you're going to do is go to the calculator, and you're going to put in 8 and then a bunch of 7s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to do about 12, and then I'm going to do menu 22. And then, oops, I don't like that. That's not a good sign. When you get a bunch of numbers like that, that's not a good sign. Let's try that again. I'm going to do 0.8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And now I'm going to do menu 22. And then, all right, there, that's better. Like if you get something like this, then that's, if you get a fraction like this with a bunch of digits, then that's good. It should be something simple like this, 79 over 90. So 79 divided by 90, press enter, and that's right. Let's do a couple more. So this is 0.3, and then it's a bunch of ones. Do about 15 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then do menu 22. And then approximate it. And it says 14 over 45, that's about right. I'm trying to do it in my head. I would say that's about right. Yep. Let's do one more. This is 0.95. So we're gonna do 0.95, 95, 95, 95, 95, 95, 95, 95, 95, and then menu 22. And it says 95 over 99. So 95 over 99. And that's wonderful. All right, so let's go back. One more thing here. Now, this last one is really what we're after. It's when you're given a number, you should be able to tell me if it's rational or irrational. All right, so let's look at a couple of examples. All right, so now this is a good one. So it says 0.39, 399, 3999, 39999, 3999999. So each time it's adding a 9. Now, even though this has a pattern, it's not a repeatable pattern. And what I mean is, if it was 393939393939, then that would be rational. But this pattern here is we're adding a 9 each time. So that's not a repeatable pattern for us. So you would say that this is irrational. And the reason is because it's a decimal that does not repeat or terminate. And so you would submit it, and they would say that's a good answer. All right, now, this one, if you don't know that this is, I'm gonna get rid of this, menu 14, 15, all right. If you don't know that 49 is a perfect square, then just put it into the calculator. Just go the square root of 49. Now you see, it gives you an integer. So you know that this number must be a perfect square. If you take the square root of a number and you get an integer, then that number must have been a perfect square. And it is. So you would say this is rational, and it's because you took the square root of a perfect square. 49 is a perfect square. 7 times 7 is 49. All right, let's do a couple more. All right, this one, 0.4, that is rational. And the reason is because it's a decimal that terminates. That's an easy one. If it ends, then it's got to be rational. Let's do a few more. Oh, here's another one of those. This one is 8989, 8999, 89999, 899999. So you can see, just like the other problem, you're adding the 9 each time. So even though that's a pattern, it's not a repeatable pattern. If it was 898989898989, that would be a repeatable pattern. So you would say this is irrational, and it's because it doesn't terminate and it doesn't repeat. So you would say, yeah. All right, good. Let's see what else we got. All right, again, if you don't know that 36 is a perfect square, just put it into the calculator. And you'll see it's an integer. They give you 6. So that means that this is rational. And that's because you took the square root of a perfect square, which would be this choice. And that would be it. All right, so let's do a couple more. 0.68 is rational because it's a decimal that terminates. That's a pretty simple one. Let's see here. This one, square root of 53. Now this one's a good one. Square root of 53. All right, boom. Now you see all these decimals. I'm gonna make this larger so you can see it better, because I need you to see this. All right, it has 2801098898. And then I'm gonna copy this to see if there really is a pattern, and there isn't. 280109889280. This is a bunch of random digits after the decimal place. And even though the calculator ends at 5, the number actually goes on forever. So we would say that this is irrational. And the reason is because this number under the square root is not a perfect square. So we would say that's a non-perfect square. And then you would submit it. One more. All right, this is a rational number because the decimal terminates. And that would be that. Let's see here. Oh gosh, another one of these. 29299. Let me take a picture of this real quick. Boo, boo, boo. And I'm going to mark it up. All right, so this one, it's adding a 9. So it adds a 9 here, and then it adds another 9 here. So this is 1 9, this is 2 9s, this one has 3 9s, this one has 4 9s, this one has 5 9s. So this one would probably have 6 9s. But even though there's a pattern, this is not considered repeatable. If it was, let me make this, if this was 2 9, 2 9, 2 9, 2 9, ... then this is rational right here. This up here is irrational. All right, so let's go back to delta. It's irrational, and it's because it does not repeat and it doesn't terminate. So you would submit it, and that would be it. All right, so guys, that's how you do these particular questions. So if you have any questions about this, come see me. I hope this has been helpful. I'm signing off.